Hello, and welcome to the Vandal Theory, a podcast about science and research at University of Idaho. I'm Danae Lenz, the External Communications Coordinator at U of I, and the host of this special summer season, where we're diving into short episodes on research that matters to Idaho. Today we're discussing the future of farming, starting with the soil beneath our feet. Our guest is Shrestha, a U of I engineering professor who's working to improve soil health on the Palouse and across Idaho. He's developing affordable soil sensors and exploring the power of biochar to help farmers conserve moisture, increase yields, and build a more resilient, sustainable future for Idaho agriculture. Let's dig in. Hi, Deb. Welcome to the Vandal Theory.
Hi, Renee.
We're going to be talking about biochar today. Can you explain what biochar is, how it's made, and just a little bit of overview of what it does?
Sure thing. So biochar is, as name implies, it is a charred biological material. Charred means when we burn biomass, it turns into ash. But if we deprive biomass from oxygen and heat it very high from, let's say, 406 degrees Celsius to around 600 degrees Celsius, instead of turning into ash, it turns into char material. The gaseous fraction is called syngas. The solid fraction is the biochar, and the liquid fraction is called pyrolysis oil. So biochar is just a solid fraction of that process. It's called pyrolysis process, and it has a very nice properties like very high surface area. It can retain moisture long. It is an organic matter, and it's a stable form of organic matter. A good portion of that biochar stays in the soil for hundreds, if not thousands of years. So it gives a long benefit to agriculture and applied.
So you work in the Palouse, obviously. What is happening to the soil in the Palouse, and how do you think this biochar could help that specifically?
Palouse is a very unique landscape. And because of that rolling hills, a lot of the fertile soil, they roll down during tillage or things like that. So also the moisture tends to roll down the hill. So if you look at the top of the Palouse hill, it has very thin layers of topsoil, and also it cannot and will not hold moisture too long. During the growing season, because of the lack of moisture, the yield is very low on the top of the hill compared to the bottom of the hill. You can notice that probably this is the time of the year in the spring. If you go around and look at this Palouse hill, you will see the bottom part of the crop is much lush and green than the top part. That's just because there is not much of a moisture and the soil moisture is thin. So when you apply biochar on the selective part of that field, like in the top of the hill, it will, it has shown in the laboratory that it will retain more moisture throughout the growing season. And that will help retain more moisture, retain more nutrient along with that, and also improve the quality of soil for a long time.
So biochar has been around for a little bit, but it's been expensive. It's still expensive. I know you would like to bring that cost
Yeah.
down. How do you expect that to work? How would you like to see that play out?
Biochar currently is like chicken or egg problem right now because there is not much of demand. The supply is limited, and people have been using biochar at higher cost to their garden where they don't have to worry too much about the return on their investment. But when we are talking about 2 million acres of Palouse land, putting biochar across these 2 million acres is very costly. And with the current rate, the return on that investment is somewhere between 40 to 50 years. So applying biochar uniformly across the field is out of question for now. So what this research will do is that will narrow down the areas in the Palouse Hills where the return on investment is the highest. As we talked about, where the soil is thin and where you need to retain more moisture, will have the highest return on investment. The research we're going to do is apply the soil moisture sensors into the different parts of the field, south facing slope, north facing slope, and top slope, and it record moisture and temperature throughout the growing season with and without biochar. So we can quantify which part of the field benefits the most by using biochar at what quantity. So that information will be provided to the farmers through and applications like farmers can use in the future using a software to see where in the field they should apply. So that will create a market for it. On the other hand, we have millions of tons of wood waste in lumber mills, which is half of that is currently used in their furnace to treat the wood. Of the remaining other half, about half of half goes to the landscaping market, and the remaining 25% is sold to a very low end market, if at all. So for that portion of the wood waste, even $30 per bone dry ton would be a lot if they could get it. Otherwise, lumber mill will just have to give it away. So we're hoping that this chicken or egg problem will be solved by quantifying the benefits to applying the fuel. On the other hand, since we have a supply at the very hand, increasing the supply and demand at the same time, hand in hand.
You mentioned the sensors that you guys are using. Can you just get into more of the technical details of that? I know you guys made them from scratch. So, yeah, just tell me a little bit more about those.
We are very proud of the development on the sensor front as well. So current soil moisture sensor cost upward of $300, $400 per unit to put in the soil. And what we were able to do it is take a very inexpensive soil moisture capacitive soil moisture sensor that you can buy it for a few dollars and improve electronically so that it will read more consistently to the moisture and calibrate to the Palouse soils. Once you do that, the readings are very consistent. And we added the radio communication system to the whole system. So it's a small board that takes that low cost sensor, add the electronics that it needed to do the signal processing, and then we bury that into soil at two different depths, so 1 feet and a 2 feet depth about. And it transmits the soil moisture and soil temperature data throughout the growing season, and we expect it to last several years in one single battery charge. So very energy conserving type of soil moisture sensor. So that is the soil moisture sensor we have deployed. The reason we went with this is we need a lot of soil moisture sensor to do the modeling of how soil transports and the profile to get the soil moisture in the whole profile. We need that dense moisture. We have employed 270 sensors in about zero point 0.1 acre of land. So there's a lot of sensors.
So, what is your ultimate goal with this? What do you want to see happen with this research?
I mentioned that the quality of soil in Palouse Hills is degrading, and then on the other hand, we have some wood waste that we are not using it currently. So it will increase the quality of soil and sustainability of agriculture while making the soil quality better for farmers for a long time to come. On the other hand, it will also increase the supply side. So I would like to see an industry, biochar industry in Palouse or in Idaho in general, that will take that agricultural waste material, turn into biochar, and apply into the field. So it is a win-win-win situation. Not only in the northern Idaho, we have a lot of dairy waste, dairy manure waste in southern Idaho that can be turned into biochar, and they have a very different properties. So I'm hoping that we can combine these biochars with different properties to tailor that will best benefit the soil in need for a sustainable agriculture. As we see the agriculture now has to be adapted for the climate change and whatever is going to happen in the field by adding this biochar will make soil more fertile for a long time to come. So that's what I want to see an industry, biochar industry in Idaho.
Thank you so much for being on the podcast today. This has been a really interesting conversation.
Thank you, Dene, for the opportunity to spread the word.
Thanks for listening to the Vandal Theory. You can learn more about this project and other research at uidaho.edu/vandaltheory. Email us at vandaltheory@uidaho.edu, and don't forget to subscribe, rate, and review wherever you get your podcasts. I'm Danae Lenz. See you next time.